talk about in this session is knockout. Before I get started, the slides to this are at holub.com/slides. And they're also going to get a conference site. The reason I bring this up is that there are two approaches one can take to a code-intensive class, which this is. One is for me to sit up here and type, and the other one is for me to show it on slides. And I get personally frustrated when I go to somebody typing kinds of classes. Is that I know that my experience is that people fall into one of two categories. I get frustrated because when I get home, I don't have a clue what the guy was typing. So I usually will believe that whatever they're typing works. So I don't really need them to type it just to prove to me that it works. So by doing slides and putting the code on the slides, then you'll have the slides and you can actually have some examples that you can look at from the templates. So they'll be up on the conference site, but they're also on my site, holub.com slides. I also want to spend just a minute talking about Angular. I don't really have slides about Angular because there are sessions on Angular. But Knockout and Angular are really two ways to do the same thing. So a little bit of discussion about Angular is worth bringing up. The main issue here is the syntactic one. I actually prefer Angular syntax to Knockout syntax. Because Knockout syntax is very HTML-like. It does everything by using special styles and that kind of stuff. It's sort of like Bootstrap and Angular uses those cool double curly braces for doing bindings, and that's a good thing. I like that. So on the Angular wins on the syntax side easily. On the what it does side, it's kind of a mixed blessing, as Angular is a much larger package than Knockout is. Because Knockout just does bindings, and we'll look at how all those work over the course of the next hour and a half. Angular does a bunch of other stuff, which means that when you download it, it's much heavier weight. There's a lot more to it. It's going to take longer to download. It takes longer for the page to become active once the page comes down. So with all of these systems that are doing magic at some level, the way they do their magic is as a side effect of the page load completing. Some JavaScript wakes up and then does a bunch of stuff to the page before the page displays. And Knockout does less of that than Angular does. So as a consequence, the page will be snappier when you launch it. This may or may not be a factor. If you're thinking about targeting mobile, it might be a serious factor. So something you might want to look at, in other words, at both systems and measure the load and launch time to make sure that it's adequate. It's nice to have two options. So I haven't given up on Knockout entirely. It's that I have some Knockout applications and I have some Angular applications. But they're both basically doing the same thing in terms of the core functionality of the libraries. The other thing I'll say is that the computer industry is a very fashion-driven industry, as much as the clothing industry. And Knockout is out of fashion this year, but it was in fashion last year. Who knows what it's going to be next year? So right now, Angular is in fashion, so everything you hear is Angular, Angular, Angular. But that's likely to change next year also. So who knows? Now, Knockout was invented by Steve Sanderson. There's a bunch of useful tutorials on Knockout on Steve's site. So I'll just point you there if you want to have some tutorials to complement this class, to fill in this class. He works for Microsoft now, but this has nothing to do with Microsoft. Is that they hired him, I'm sure, because he built it. It has nothing to do with Microsoft. So, you download it just by downloading it. It's one package. You include it at the top of your web page, and it comes down. It works on pretty much every browser on the planet, which is a good thing, including the mobile versions of all these browsers. So we don't have to worry about that. Now let's talk about philosophy, though, before we start looking at the syntax of the system. And what I'm about to talk about architecturally applies just as much to Angular as it applies to Knockout. Now, from an architectural point of view, not just the web, but UIs in general present some interesting problems. The main issue here is that when you're maintaining code, you want to, as much as possible, guarantee that all changes occur in one place. Because from a maintenance point of view, if you change one thing, you've got to change 6 other things in 6 other different places. It's just too hard. Now there's a classic UI architecture which people use, I don't know, for ritual reasons, to go back to my keynote, which is the model view controller architecture. Model view controller was invented by Goldberg in 1967. And I try and think about anything else in computing that was invented in 1967 that we're still using. Now, there's a reason for that. Is the stuff that we came up with 30 years ago isn't usually very good. So we've had 30 years to think about the problem. For some reason, though, people use model view controller in a mindless way without thinking about whether it's a good thing or not. Now, model view controller has a couple of significant problems with it. The main one is that it doesn't actually do what it promises. In other words, model view controller is supposed to separate the UI and the business logic. So there's 2 questions there. First one is this a good thing? And secondly is, does it actually do it? And the answer to both of those is no. So let me talk about the second one first. Is that if you're really separating the business logic from the UI, you ought to be able to change either without affecting the other. Well, model view controller only works in one direction. If we want to change the way that things look, then all of those changes are in one place and it doesn't affect the model. It doesn't affect the things that are feeding into the screens. If we want to change the model, we're host. Right? If you think about a pure model view controller system like Visual Basic or any of the visual tools, if you need to change something in the C# part of your program, every one of your screens is now broken. If you did this in a visual tool, you've got to go into every one of the screens, open up every one of the controls, and change the code associated with every one of those controls to deal with the new model. And that is just way too much work for me. Everyone understanding the point that I'm trying to make here? I'm sure we have all gone through this hell in the process of the model changing. So what that does, that's so hard to do that it makes people reluctant to change the underlying models, which is bad. The other thing that it does is it makes the models tend to be much more big, much larger, much more flexible than they actually need to be, which makes the code harder to maintain because it's a bigger thing that you're maintaining. So all of this is bad stuff. So the real question is, do we need to separate the business logic from the UI at all? Or if we do need to separate it, how should we go about separating it? Now I argue that we shouldn't separate it because I want all of the changes to be in one place. In other words, if I make a change to the model, I also want to make a change to the view. And I want them to be in the same place, and vice versa. Now the issue here, if we're talking about a model that's done in a good solid object-oriented way, is that the objects in your system should map directly to domain-level objects. We're doing an ordering system. The objects in that system, the classes in that system would be orders, order items, customers. Customers might have address objects associated with them. But all of the key classes will map to the domain level. This is the subject of the class that I gave on Monday. Is how to write code in such a way that the domain is reflected directly in the structure of the code. Because as soon as the domain is not reflected in the structure of the code, as soon as you look at the class names and they have no connection with the domain of the program, then when you need to make a change at the domain level, there's no obvious place to go in the code to make the change. In other words, when a requirement changes, you want to know exactly where to go in the code in order to satisfy the new requirement. Well, if there's not a direct mapping between the domain and the code, then you can't do that anymore, which makes everything harder. In the Agile world, it makes it impossible. In other words, if your code is not organized in the way I describe it, you can't really do Agile development because it's too hard. There's too many inefficiencies, too much slowness added to the process of making a change when a new requirement comes along, and new requirements come along all the time. So structuring your code in that way is extremely important, more and more so as we move in the direction of Agile processes. Now, the problem with model view controller, though, is that typically it doesn't encourage you to do that. So if we're going to go into a system where we can have the model map directly to the domain, we have to think of UI architectures other than model view controller. And MVVM is a lot better in that way. which Knockout and Angular both really are kind of MVVM frameworks. So the basic idea here, though, is that when a UI designer looks at a UI, or when an OO designer looks at a UI, what he's saying in his head is, what I'm looking at is a composite user interface that is manufactured from smaller user interfaces, each of which maps directly to one object in the system. All right, if you look at the checkout page, there is an order object, which is the big screen. But an order object is made up of a customer object, which will be your shipping information on one side, and set of order item objects. The customer should produce its own user interface. The order item should produce its own user interface. Right? Small, self-contained, focused on the same things that the object itself is focused on. So what that means is that if a change happens at the order item level, I go look at the order item UI, and I make the change there too, and I'm done. Is everyone following what I'm saying here? That's a much easier situation for all of us than we would have if the order page was just one giant monolithic page, and every time I changed anything that was item related, I had to go into that monolithic page and make changes. Now, there are lots of ways that we can accomplish that kind of architecture from a implementation point of view. You can have pieces of the system, the purpose of which is to generate other pieces of the system, and so forth. But with web-based applications, we don't really need to do that at all, particularly in the brave new world of single-page web apps. Because what we have for our web application is really just one page with a bunch of divs on it. And the divs can pull down whatever code they want into themselves. Is everyone understanding what I'm saying here? In other words, a page can pull down an order item UI from the server as it loads. So we can actually take the order item UI and split it up into a separate file if we want to. Nowadays, a lot of big pieces of the UI are built in JavaScript anyway, which we have to pull down using some kind of, it's one of the 2 or 3 elements that you can use to pull JavaScript into your page. But the point is that it really doesn't make much difference significantly in terms of load time if you're loading 10 very small things and loading one thing that's 10 times as big. It used to be a problem because the sockets would get closed and reopened again, but modern browsers don't do that. They leave the socket open and they just load the files down. So practically speaking, there's really no difference. So we should be organizing our code then to make it more maintainable. So we're getting to this brave new world. We want all of the changes to occur in one place. And we want to never have to duplicate work, is the other side of this, particularly in the user interface. So the other advantage of the approach that I'm suggesting is that if you have the customer UI as a single standalone component, if you will, every place a customer is displayed on your page, you can pull down the customer UI. If you want the customer UI to represent itself in slightly different ways in different contexts, you can pass that information into the URL that's used to pull down the customer UI. But the point is that you're not duplicating work, as you implement the customer UI once, and then you might use it in 40 different places on your website. That's a much better place to be than if you have a customer UI actually embedded in 40 different web pages. Because again, the changes are too hard. Is this making sense to everyone? So from an architectural point of view, we want to be thinking about components. We want to be thinking about little objects. And people say object orientation is dead, which is nonsense. It's the best programs have functional elements, they have object-oriented elements. But more to the point, microservices are a big deal. And from my point of view, anybody who's doing anything that's got a server-side component that's not implementing the server-side in microservices is probably doing it wrong. It's not that microservices can solve every problem, they can't. But they can solve about 80% of the problems that we all have in really elegant ways. They're more maintainable, they're more scalable, they're just a better approach. But really, there's no difference between designing the interface to a microservice and designing an object. It's exactly the same process. A microservice really is an object. It's just an object that's implemented as a process, rather than being implemented inside your processes as a separate compilation. So we're moving in a modular direction. It's kind of the point that I'm trying to make in terms of the code that we all have. So what this lets us do then is we have a situation where every object is effectively displaying its own user interface. Right now, they're separate files, right? The HTML/JavaScript file that comprises our customer UI is going to be a separate physical file than the server-side file that defines the server-side logic associated with the customer. As far as I'm concerned, that bundle of files is the object definition. And so I'm not advocating at all that you should write C# code to generate HTML. But what I am advocating is to conceptually think of an object as being now a bundle of different pieces written in different languages. And one of those languages will be JavaScript, and one of those languages will be C# or Java or Ruby or whatever your server-side language is. And one of those languages will be HTML5 if you want to call that a language. And it's the bundle of them that comprises the system as a whole. So, model view controller, just don't do it. It's just not really a viable way to work. So what are we doing then if we're not doing model view controller? Right? Is that, well, this slide is just talking about what I was just talking about a moment ago. The problem is the proliferation of views, the fact that there are too many views and that maintenance is just too difficult. What we want to be thinking about is data abstraction. And we want the scope of change in one place, and we want to abstract our objects, our data into this notion of centralized objects. Objects have to render themselves. All of the changes are in one place. The object is represented consistently across the entire user interface. You make a change in one definition of a customer UI, and customers are represented differently everywhere in your program. You know, that's a great place to be, right? As I add a new field to the customer and suddenly 40 pages change and the customer's new information is represented on all 40 of those pages with having to do work in one place. That's what we're trying to accomplish. So we're thinking in terms of objects. I have a server-side employee, I have a bunch of pipes, I have a client-side employee. Now, conceptually, I think of the server-side employee and the client-side employee as being the same object. It's just kind of bifurcated into two physical halves because of the needs of the UI system that we're building. And that's an important concept also. In other words, I don't think in my mind of the JavaScript object as being a separate object from the C# object that's over on the server. As far as I'm concerned, they're the same thing. So, when you're talking about the system running at runtime, what we really have is an object that has some logic running on the server and some logic running in the browser. And they've got to somehow send state information back and forth in order to keep synchronized, because that's the plumbing that's involved. So JSON is the way to do that. So our basic idea then is that the server side can provide information to its client-side component by passing some JSON across. And by the same token, if the changes happen on the client side and it needs to get the server updated, it sends some JSON back over to the server. And that back and forth might happen several times as the object runs. But this is just plumbing. This is not architecture. Right? In other words, it's maybe if you look at it at a high level, it doesn't impact the architecture at all. If you look at it at a very low level, it does. But the basic idea here is that what we've got is one object split into two pieces that's using JSON, and the two pieces are using JSON as a means of communicating with each other so that they can synchronize with respect to state. So everyone with me so far? Now, I consider this JSON then to be part of the server-side object, not really part of the UI. It's server-side state that's being injected into the browser. So the problem that we need to solve then is that the user interface itself, it's got to connect to the JSON also in order for things to work right. And we want that connection to be as painless as possible. So I think really of the server-side object as being this piece, and the client-side object as being this piece. I guess we could call it a view for lack of a better word. And I want changes here to be reflected there automatically and vice versa. So I don't want to have to worry about this plumbing at all. I want that to just happen. And that's what Knockout does for you. That's also what Angular does. So the goal here then is to make sure that this synchronization happens as painlessly as possible with as little work having to happen on our part, so we can focus on this layer, which is something that you can't automate easily. So when the change occurs there, it's reflected automatically. And it's also reflected automatically in the server, ideally. Okay, now Knockout doesn't do that part. I wish it did. Angular doesn't do that part either. I wish it did. In other words, I would really like to have something that handles all this plumbing for me. And there are no systems that do that. It's not easy. But at least it'll handle this part for me. So the goal then is to keep all three of these in sync. All three of these layers in sync with each other. And it should work in both directions. If something changes on the server side, it should also change on the client side. Okay? So that's our architectural approach. Knockout is the solution, is the solution for that job. As is Angular. Everything I just said applies to both forms. So let's look at how all this works. Knockout is based on a system called system of things, which it calls bindings. Here is the simplest binding in the Knockout world. Here's what we're displaying. This is what you see on the screen. So I've got two simple HTML elements. Inside them are a sub-element. In this case, it happens to be strong, which puts it in boldface. This could be anything, though. This could be a span. It could be a div. It could be anything you want. Any HTML element will do. The Knockout component is this data bind thing, which is, as you know, not part of HTML. But all of these systems work in this way, as they introduce new attributes to the HTML tags that are mysterious. Now, the way they can get away with this is that if you look at the HTML spec, HTML will happily allow this to happen. The HTML spec says that if you introduce a new attribute that is not meaningful, the HTML processor should just ignore it. However, if you traverse the DOM using JavaScript, you can see these. So if you write a little bit of code in the JavaScript level that traverses the DOM, it can ask every element in the DOM, show me all your attributes. And it gets the whole list, whether or not they're legitimate HTML5. So when Knockout wakes up, it searches every element in the DOM, looking for data bind attributes. And when it finds them, it generates a bunch of JavaScript that does some work for us. So in this case, we're telling it what kind of binding is. I'll get back to this text point in a second. There are several categories of bindings that we can have here. But then I've associated a name with it. Now the other part of Knockout, which is consistent through all of the things that we look at, is this notion of a view model. So the basic idea here is that the view model is the data representation. It's the thing that is a JavaScript object that reflects state that exists on the server. Now, of course, JSON is doing nothing but defining JavaScript objects. Right? The JSON syntax is the JavaScript syntax. So that's why JSON exists, right? Is that if you bring JSON down and you append x equals to the front of it, you can say to JavaScript, run this, and it will produce a variable called x, which is an object that holds the fields that are defined in the JSON. So this view model could actually be downloaded from the server if you want to. More often than not, what people do is leave the view model in the client-side code and then just download the fields from the server. But however you do it, doesn't really matter. One way or another, though, we need a JavaScript object which defines the fields that are going to be of interest, the ones that we're going to bind to the UI. Now, what we're looking at here, for those of you that don't know JavaScript a lot, is JavaScript is a hardcore functional programming language. People want to try and make you think of JavaScript as if it's an object-oriented language. There are lots of books written to that respect. It's a push. It's really a stretch to try and turn JavaScript into an OO language, because it isn't. It's really a functional language. So an object in JavaScript is really a function. And that function has a certain amount of state information associated with it. If you know, who's worked with the functional aspects of at least C# or Java or one of those languages? Anybody? Just a couple of them. You need to. This is the direction that we're all moving into. If you've been ignoring lint because it seems weird, stop that. Is that you have to learn how that stuff works. And if you're using, what languages are we using? How many C# programmers do we have? Almost everybody. What about Java? Anybody? Okay, that covers this, right? And the Swift, the other functional programming language, which is going to become very popular, is Swift. I'm doing a class on Swift on Friday, but the entire Apple ecosystem is moving to Swift. So, but they all use almost identical syntax to describe the functional programming sides of things. I'm going to digress here a little bit, so I might end up having to skip quickly through the slides at the end, but this stuff is important. The basic idea of a functional programming system that's different than an object-oriented programming system, just so that you can understand where I'm coming from, is that when you're in a function, there is a set of data that is available to the function as it operates. That set of data is the set of arguments, the set of local variables, the set of globals, and if it's an object-oriented language, the set of the members of the class that the thing is a method of. When you execute an object, any function, that collection of data is said to be captured by the function. All right, now, that notion of capture is very important. So the way you should think of this is that every function has attached to it a little object that has captured all of the data that's available to the function. Now, in a traditional object-oriented language, once the function returns, that captured information is released. Right? It just goes out to wherever it went, wherever it was before you entered the function. In a functional language, that captured information has a lifetime that is longer than the function. That's the one big deal. So what that means is that captured information, if you have a pointer to a function, for example, that captured information is effectively stored as part of that function pointer. So that when you execute that function, even if you execute it later, you can still get the information that was captured inside of it. Is this making sense? Is that I can do a whole, maybe I should do a whole session on functional programming at some point, but this is the core of it, is the notion of capturing data. Right, so that's exactly what's happening with this object here, right, is that what we're doing here by saying this dot first name, this dot last name, is we are actually adding elements to the capture, which can be accessed from anybody who calls or somehow uses this function. Is everyone with me here? That's effectively a kind of object. Right? But in order to make things make sense, if you think of JavaScript as a functional programming language, it makes way more sense than if you start trying to somehow turn this into something object-oriented. Because here we have runtime code that's manufacturing an object, which makes no sense from an OO point of view. But it makes a lot of sense from a functional program. All right, so what this is doing then is this is effectively a constructor for an object. Is that if I run this function, it's going to manufacture an object that has two fields in it. Okay, is everyone with me so far? So down here, what I'm saying to knockout is I want you to apply all bindings to an instance of this object that we are specifying in this function. What it's really doing from a functional programming point of view, the new keyword in JavaScript is a no-op. It does nothing. So what's really going on here is that it is executing this function. The function generates a closure, it generates a capture, and it returns that capture. So what's happening here is apply bindings is being applied to this capture. Okay, is everyone with me here? So what we have effectively done with this call is we have allowed knockout to access everything that's defined in here. So the flip side of that is is that knockout can't access anything unless it's defined in there. Right? So this is the server-side chunk of our communication system, and then this is applying a connection to the UI. So up here is the UI. And what this binding statement is saying is the first name field in this capture is going to be attached to this element. So that when this element is displayed, what it is going to display is whatever value is in here. If I change this value, this text up here will just magically change. We don't have to do a thing. Because knockout is taking care of the glue that connects the object here with the UI representation. Is everyone seeing how this is working? And if we were in Angular, the only difference would be instead of saying data binding, there would be a curly syntax used to do the binding. So you'd say curly first name equals curly. So it's a little cleaner. It's Angular syntax is a little bit cleaner. Okay, is everyone with me here? So this is a very simple data binding damage. We're creating a JavaScript object. We've told knockout, I want you to use that JavaScript object for your state. So knockout can now access everything in that single JavaScript object. And then up here we're saying, connect this piece of that JavaScript object to this element. So now when I make changes at the JavaScript level, the element changes automatically. And all of the infrastructure needed to do that, right? And inside here there's an event model, obviously. So there's got to be some kind of event generated, and we have to send that event to some JavaScript that's going to intercept it and update the DOM, right? That's what knockout does, is that piece. All right, now if all that it did was, even if all that it did was display stuff, that would be pretty cool. But it does, fortunately, do other things as well. It can go in both directions. So here I have an example of a simple dialog box where I've got a couple of input fields and a couple of output fields. And what I want to do is I want to type something here and I want it to change there. Now in order to do that, it is also going to change inside my view model. So it's actually changing in two places. It's changing visually and it's changing at the model level as well inside the JavaScript. So how are we making that happen? Well, first of all, these first two data bindings up at the top are the ones we were just looking at. So there's nothing particularly earth-shattering there. Is that, in other words, when first name changes, then this element's contents will change and this thing will update. The new parts are the inputs, the two input fields, which have a different kind of data binding. This is a value type data binding rather than a text data binding. Text is an output, value is an input. So what it's doing here is that it's still connecting to the same variable. So this binding is saying, I want you to look for changes in this variable. Is everyone following me here? So, and it's also going to bind, of course, to the data script object, to the JavaScript object. So I enter some text here, and that causes a value to change here, which causes an event to be sent to the JavaScript. We're not seeing that because, again, knockout is dealing with it. Knockout intercepts that event and says, oh, I've seen a text change event, but I'm bound to first name, so I'm going to go down here and change first name. Is that everyone with me here? Then knockouts, the older, as I said 5 minutes ago, stuff we were just talking about kicks in. And knockout says, oh, something just changed first name. I guess knockout is kind of schizophrenic here. It doesn't really care whether it was itself that changed it, but something changed it. So that kicks off another event, which causes this to be updated to reflect the change in the JavaScript object. Is everyone seeing how this is happening? So what this binding is doing is it's intercepting events coming in from the UI and using them to modify the JavaScript. And what this binding is doing is detecting changes in the JavaScript and using that to modify the user interface. So we get a connection in both directions. All right? Questions? I always get nervous when I do classes like this and there are no questions. I can't believe that I'm that lucid, particularly to what is me early in the morning.
Presumably these kind of updates are going to carry through even if we're using JavaScript to manipulate these elements that I wrote some JavaScript.
Yeah, if you write some JavaScript that manipulates it, the same thing happens. Right, so if you write some JavaScript that manipulates this directly, it'll happen.
What about manipulating the DOM directly? So if I took the strong element and changed the text.
That's going to confuse the problem. I don't know. I've never done that. My guess is it's going to confuse it. Because it does it handles the bindings only once as part of the page load.
Right.
So if you call apply bindings a second time after you modified your DOM, then I think it would work. But you'd have to call apply bindings a second time in order to get it to reload its own internal system. I haven't personally done it though, so I'm guessing here.
In the background, what events is actually looking at? Sorry, in the background, what events is actually looking at? Is it looking at all the events, but some of them?
Well, the combination of things is up here. It's looking at the JavaScript events, and it can hook up to all of them. So we'll look at that in a second. In the other direction, it has its own event model that's just invented, and it's using its own internal event model and going in the direction. So it has its own list of the whole sub-thing. Okay?
This example, if we modify the model on the client side, like through JavaScript, would it affect the UI on PostgreSQL or just like this model?
Yeah.
If you get grab of it and set the first name using JavaScript,
Yeah.
what happens to the UI?
It'll update.
What's the text, the input, and the display?
Well, if you were to use JavaScript to affect, if you were to use JavaScript to change this, then that's going to be updated. If you use JavaScript to inject text into the input, I don't know, I haven't tried that. I guess it would work. It's kind of a roundabout way to do something though, so why would you want to do that? It's not something that I've ever wanted to do. Right? But certainly changing this down here will cause that to change, no problem. Okay? Now let's make it a little bit more complicated, because I want to add some thinking here. In other words, here I'm creating a full name that concatenates the first name and the last name, and I'm going to do that in code. So the top looks pretty much the same as it did before. The main difference is I'm adding this element here, which is a value which is turning into that. All right, so everyone with me here? Now, the new piece is in my view model. Inside my JavaScript, I am providing a function. Remember, JavaScript is a functional programming language. This function, interestingly enough, will capture all visible data. So this function is going to carry around a capture of first name and last name along with it. Is that everyone with me here? If there were multiple functions inside the view model, all of them would capture first name and last name. If any of them changed either first name or last name, all of them would see that change. That's the way captures work. Even if I were to take this function and return it and stick it somewhere else in a global variable, it would still be able to access first name and last name. The lifetime of the capture is longer than the lifetime of the function within which the capture was created. Okay? So, what this is doing is I am first of all specifying a function at my level that's doing a little bit of work. Is that it's concatenating the first name and last name together and it's returning the new value. And the knockout is wrapping it in a function of its own, which is saying, I want you to treat this function as something that is computing a value that's going to be put into full name, which is going to end up here. And it does that because it has this data binding. Is everyone following what I'm doing here? Right? In other words, full name changes, so this data binding will recognize that and update this field. But in order to make that magic happen, we need to do a little bit more than just change things. We have to tell Knockout, you've got to look for changes to happen. Okay, is everyone seeing how this is working? So now we can write whatever arbitrary JavaScript we want. This is just trivial, but we could write anything we wanted.
Can you also say have full name as an input field and then so when you change the input, it has the
Well, notice that this full name is accessing first name and last. Well, it's accessing first name and last name. Are those my input fields? Oh no, it's accessing the fields down here. Right? But it could pull stuff out of the input field if you wanted to.
So as in, if you have an input field which is bound to full name, and then whenever you change that, it takes what you've got and
Yes.
sets up, and then it triggers it.
Yeah. That was fine. Okay? Is this making sense to you? So I want to do a little bit more here, so I'm adding another one. I want to capitalize the last name. So I've added another plain old function here that modifies last name. Is everyone with me here? But now I've added a new little trick, is that I've made last name an observable thing. So what's happening here now is that Knockout is observing last name. All right, and the click method here is a binding. This is another kind of Knockout binding. That's saying, okay, I'm going to bind the click on this button to the capitalized last name method. So when the click event occurs up at the button, capitalized last name is called. That executes this code, obviously. This code modifies last name. Last name is something that Knockout is observing. So it sees the modification and gets everything updated as we would expect it to.
Does it not modify within the last name input field, though? Only within the text?
That's right, because it's just this one. Well, because of this binding.
Right.
Right? You could do it in both, right? You could bind it to both. But in this particular example, it's not bound to both.
Previously, we said that actually model could be returned as an object from your service.
It could be returned. Well, the view model could be returned. The entire view model could come down from the server side, but it would be coming down to JSON, right? So you have to put a little bit of context around it in order to make it compile on the JavaScript side. But just this much is effectively JSON, right? Or it could be JSON. More often than not, as I said, though, what you'll have is a view model that has a JSON variable in it. And instead of saying this first name and this last name and this full name, what I would have is this dot state equals that big JSON thing that I just got from the server. And then down here, in any place I was accessing things like this dot last name, I would be saying this dot state dot last name.
So you have to bring down the care about.
Yeah, so you have to bring down all that other stuff. Yeah, exactly. Okay? This is about the point where people's eyes start glazing over as we're starting to get more and more complicated as time progresses. So this is why I want to give you slides instead of just sitting up here typing. Right? If I was sitting up here typing at this point, everything I typed beyond this point would be completely lost to you. So at least this way you'll have the slides to look at later. So we have a lot of bindings available that we can hook up to things. We've seen text already. So what text says is just display whatever element you're bound to. The other ones are pretty useful though. Visible, for example, is that it's actually looking for a true-false value on the bound thing, and it will make the element either visible or not, depending on whether the bound variable has a true or false state to it. And we'll see in a moment we can actually combine these if we want to. So we could actually combine text and visible so that the text would only be visible if one variable was true, but the text that was being displayed would be coming from a second variable. We can combine. The data binding as an HTML element lets us put sort of arbitrary HTML into the element as a side effect of things changing. I'll show you an example of that. But we'll see examples of most of this stuff in a moment. The point that I'm trying to make here is I can change the CSS as a side effect of variables changing. I can change the style attributes based on variables changing inside Knockout. And I can change the entire HTML that comprises the object, the DOM object, based on things that are happening inside variables that Knockout is observing. Now let's look at attributes. That's an interesting one also. So here I have an anchor element that is bound to an attribute using the attribute binding. Now, you'll notice that everything in the anchor element is part of that binding. In other words, there's no href field here, if you will, no href attribute in the A element itself. So the way this is going to work is Knockout is going to supply href and title attributes to this anchor element. All right, so here's my little script that's going to make this work. I have a little view model. I've said the URL, that's this one. So it's not an accident. These two are the same name. The URL is something that is observable by Knockout. Is everyone with me here? And what it's going to do is it's going to inject this text into the URL when necessary. By the same token, details, and again, it's not an accident that these are the same name, is a Knockout observable thing, and this text will be injected in here when the anchor element is displayed. So now we have a situation where strings of course are trivial, but I could be pulling down data from the server and causing that to change the behavior of an anchor attribute inside my system automatically without having to search the DOM and find the anchor element and do all the JavaScript that we would need to change the way that the anchor element works. And given that this anchor element could appear in 6 places on the page, that's pretty convenient. So that's everyone with me here. And this is working in this case, with the href and title elements or attributes, but you can use this with any attribute on any element. I don't have an example. I should have added an example of CSS here. I thought I had it, but I forgot. But the CSS binding works the same way. So we can use the CSS binding to change the style of any element in the system based on Knockout bindings.
This is very nicely with things that are looking to validate your HTML. It's not going to start shouting there's no href.
It's not going to.
Start shouting there's no href tag.
No, it will not. Right, because remember, a lot of these changes will happen immediately after the page loads. Right, so nothing will have happened yet, in other words. So even if there is some kind of validation going on inside some other part of the system, Knockout will have made the swaps first, made the changes first. But you know, HTML itself doesn't complain if there's anything wrong. Right? If you load a page that's got garbage on it, the browser says, okay, it just doesn't display it. Did I answer your question? Ask me again. I'm confused.
I think more about my ID.
About?
My ID.
Yeah.
It's not going to start complaining.
Why would it? It won't. No.
It should do.
It shouldn't. It should not. And of course, you could bind the ID attribute also if you wanted to. So you could change the ID. That would be interesting, actually. Change the ID dynamically so that different elements are affected at different times depending on what the system was doing. It'd be complicated, but you could do it. All right, now Knockout also has facilities for handling lists, which are pretty useful. Look, I will say as a caveat here, though, that the code that does the list updates in Knockout is not the speediest code on the planet. Is that it does work, it is pretty convenient, but it's not very fast. And if you do a lot of list manipulation before you make the list visible, it can make the page appear to be taking an awfully long time to load and display. So you might not want to do that. Is that the list code takes a while to run. And by a while I mean seconds, it's something you can measure in seconds. So your page will appear unresponsive if you are not displaying the list until after Knockout has had its chance at it. It's all still done with bindings though. So here I have a for each binding that's associated with a table body. So what this is going to do is it's going to duplicate the contents of the T-body for every seat in this array. Here's the array indicator, here's the brackets. All right, so let's again look at the code. Self.seats, that's JavaScript, is pointing at an observable array. This was just saying ko.observable in our earlier examples. Here we're saying it's an observable array. The argument to observable array, the constructor argument to is an array. This array holds two seat reservation objects. Seat reservation is defined up here. So a seat reservation has a name, and it has an observable thing in it called a meal. Right, is this making sense so far? So the seat reservation then is going to be an array of seat reservation objects, each of which has a name and a meal. And then the meal is defined right here. The set of available meals is defined here. So the seat reservation has a name and a meal. The meal is a local thing. And Knockout, though, is dealing with an array of seat reservations. So how's this going to work? It's going to look at this binding and it's going to say for each, this is effectively saying for each seat in the seat arrays, in the seats array. And the seats array is down here, so it's going to start out with this first one, and it's going to expand out this table row to have the fields in it that are defined here in this array element. And then it's going to loop back up and it's going to generate a second table row that has the bind that's bound to the second array element. All right, is everyone with me here? Now, I look at this table element though, and what I have here is a bunch of text bindings of the sort we were looking at earlier. So the for each is basically binding this whole thing to one array element. And now what we're doing is binding to the pieces of that array element. So this is going to evaluate to the name field of the current array element, Steve, in case of the first one. And this is going to bind to the meal's meal name. Right? Remember, the second array element is a meal. It's a pointer to one of these objects. One of those objects. Everybody's eyes are getting more and more glazed over. Maybe we should all just go downstairs and get coffee and forget about the rest of the talk. It's getting kind of complicated. The code gets complicated, you know? So the basic thing I'm trying to get across here is there are two levels of bindings. One level of binding is the for each binding. And what it's doing is it is both duplicating internal table rows and causing each of those individual table rows to be bound to a specific array element. Then inside the table row, what it's bound to is that specific table element. So all the bindings up here apply to fields of that specific table element. So, in other words, when this row is duplicated, this stuff is going to act a little bit differently because each duplication of this row will be bound to a different table element, so there'll be different data feeding into it. All right, so I've used for each here, and then we'll do this duplication, but notice there's also an if and an if not and a with. I'll look at with in a second. The if basically would not do a duplication here, but everything that was in here would disappear if the if statement failed. So this doesn't have to be applied to tables, you can apply it to anything. Including a div, right, which is what it would typically be if it's an if. Okay? So let's extend things a little bit. Now here's the, I should have put this picture on the previous page, but here's the little UI. This was Steve, remember, was the name of our seat reservation, and the meal that Steve chose was a standard sandwich, right? That's this meal is the default. So what we're adding here now is a button. That didn't exist in the earlier UI. This button says reserve another seat. So here's a button, and it's bound to the add seat method through the click event. So what I'm doing now is then creating another row in this table, effectively. And I'm doing it by calling a method, right? And the method is add seat, which is, where do we go? Somewhere here, there should be add seat. Oh, it's down. Right, so I have to add an add seat function, which is going to modify stuff. Now, notice that I'm using the push function here to put a new element into this array. That's actually just part of JavaScript. Is that arrays in JavaScript are not actually arrays. Arrays in JavaScript are lists. So you can push things into them, you can pull things out of them. You're just using a square bracket, so that's the list. So what I'm saying here is now then, I want this button bound to the add seat method. Here's the add seat method, which is a function which is going to push a new element into the array with a value of no name at all, right? That's why there's no name here. And available meal sub 0, which is our standard sandwich. And because all of this is happening with bindings, all of these other bindings that we were talking about will activate as a side effect of changing the array. In other words, this for each binding is going to know that the array has just changed and deal with it. Right, and this is the piece that's slow, actually. This is the experience that I've had is that when you're dynamically changing, adding rows to arrays this way, this is hideously slow. So I'm not sure that I would do a lot of this. Is that doing it occasionally is fine, but if your page is a 400 element table where you're adding the elements dynamically in JavaScript, that's going to be completely unacceptable. It's just not, the performance is going to be just off the chart in the wrong direction. Okay, but the point that I'm making with this exercise is that here I've got a little JavaScript that's just pushing a new element into the array. So I push the element into the array, but for each binding is observing that array. So the for each binding notices that this push is happening, and it will rebuild the entire table. That's why it's so slow. It's not just adding a new element, it's rebuilding the entire table.
So it's so slow, what would you do as an alternative?
If you go, there's a tutorial actually on Steve's site you could look at that talks about it. But basically the idea is to try and hide and unhide things and change their contents rather than rebuilding the entire table all the time. Right? So you don't want to do the push. Is what you want to do is modify an existing table and then make elements visible that used to be invisible. And that's a lot faster. Right? Because the problem here is that we're like doing heavy duty work on the DOM in order to rebuild that table, and it just takes a lot of time. keep going. I'm going to add a little bit of formatting by making some more changes. So I'm getting, this is still the code, this is getting smaller and smaller and smaller, but it's the same code we've been looking at. All right, so I'm going to just get rid of these data bindings, get rid of all of these old table elements, all of these columns. And I'm going to replace them with a new set of columns. So the first one is I'm going to bind the name on the leftmost column. But now it's being bound, notice, as an input field, not as a text field. And I'm binding on the right a selector. Right? Remember, down here, this is now a selector. All right? Is everyone following what I'm doing here? Right? And it has an initial value, and it has the text of, right, this is the options list. Notice that the options list is being pulled out of the available meals array, which is down, well, it's down here someplace. It's kind of hidden. There it is. It's right there. Okay, so everyone's seeing how this binding is working. So the binding, in other words, is creating a select element for us, pulling the options out of an array that exists in JavaScript. And then it's pulling values and initial option text also out of the JavaScript. The second element here, I'm now replacing with this guy, with a formatted price. Used to be the price was just a number, but now I want to add a dollar sign. Sitting where I am, I should be adding a pound sign, but I'm not going to redo the slides. Sorry. All right, so everyone with me here? So the contents of this column now is going to be generated dynamically in the code by calling this formatted price method. Everyone see what I'm doing? This is a text binding, which is binding a formatted price, which is a computed function. We saw this a few slides back. And that function then will be executed as a side effect of displaying this bound column. So this function is going to run once for each element in that column. And what it's going to do is it's going to nicely format the price so that we get the dollar sign and so forth where we want it. And that's what place in the right place.
So, what's the dollar root?
Dollar root is the root of the. What that means is the view model. Right. So dollar root is the sort of a magic variable that Knockout supports, which means the view model. And of course, you can drill down. If the view model has things inside it, you can start at dollar root and drill down into whatever field you want to get at. Okay. Let's go even further. Right now I want to add a total to all this. So I'll add a little bit more. Now I'm adding okay, so what I'm doing now is adding this total surcharge. So up here at the top, I have to add a total surcharge. Oh, what am I doing? Oh, I'm doing two things. That's the problem. I'm also adding a remove button here on the right, remove link on the right. So up at the top, this first one is adding a remove link. This is a click data binding. You've seen that a few times now. So when this link is clicked, it's going to remove a seat. And here's my remove seat function, which I put way in there. Right, so the remove seat function is going into the array of seats and just removing it. It's the opposite of the push. Which again is going to be painful in this particular example because it's going to now redraw the table. All right, so we're over here.
So how are you providing the seat?
Well, the seats array is just down here. And remember, when we looked at the reserve another seat code a few slides back, that was pushing new seat reservations into the seats array.
But it just knows the seat because it's
Yes. Yes.
it just sets that whole row.
Set that whole rows model. Exactly. That's exactly right. All right, so everyone see what's happening here. So now I've got my remove button working. Now let's keep going. Look at surcharges. It's now. Stop it, stop it. There. So let's look at the surcharge part. Is again, I need to add another element, if you will, at the bottom of this table to indicate the surcharge. The reason I'm hesitating here is I accidentally made this 0 point in the wrong place. It should be here. Okay. So this is an H3 element. It's bound using the visible attribute we were looking at a moment ago. So if the surcharge is greater than 0, then this H3 is visible. If the surcharge is not greater than 0, then the H3 element will not be visible. Right? If it is visible, it'll have the text total surcharge, followed by, and this is a text binding of the sort that we've been looking at earlier. So whatever value is returned from total surcharge dot to fixed is going to be bound to the text. That's what we're displaying. So everyone following how this is working? So again, this is a text binding, just like what we were doing before, but now I've made it a little bit more complicated, and there's an actual method call here that's returning the value that's bound to the text. Now, we look down at the total surcharge, we're going to have to add one, add a field called total surcharge for access. This is a computed function, which is going to do the computation, right? Figure out what the totals are. It's just a loop that's spinning here, figuring out what the totals are, and returning the total.
If you have speculation and it's, what does the total show? The full array or what is up in the view?
The full array. Because notice that the total surcharge here is acting on this seats array down here. It's not going up to the DOM. So it's just going to total up this other seat array. Now, of course, if you wanted to just do the view, you could rewrite this function so it just looked at the DOM itself and pulled values out of the DOM to the total value. But this is really just arbitrary JavaScript. This has nothing to do with knockout. Right? This is just some function that's computing a value that knockout is using. Okay, I'm trying to give everybody enough time to absorb this.
How do you combine this with server-side code? For example, in this example, when you click on reserve another seat, you need something happen on server, for example, create a new record in database or something.
Knockout doesn't take care of
So it's something that we need to take care of.
communication to the server.
Yeah, of course.
So you just have to make an AJAX call and do the update.
Do you usually combine it with other things like jQuery?
Yeah, it combines with other JavaScript libraries. Works well with jQuery. I use jQuery all the time. Works well with Bootstrap, which is just jQuery.
Yeah.
So it works fine. Might even work with Angular. I tried putting Angular and Knockout in the same application. That would get confusing pretty quickly, but. Let's see, I already talked about this. Let's see what I said. All right, so we've been looking at for each. As I said, there's both an if and an if not, which will typically not operate on table rows, though they could, right? But they'll typically be operating on divs or something like that. So the whole thing will, bind or not, will be displayed based on whether a variable is true or not. Content can nest, and the with binding is useful for that. So here, for example, what I'm saying with the with, if you look at what's happening here, I have my view model, in that is, in this case, an address, which has a street and a city on it. And the street and the city are independently observable things. So up here inside this paragraph, I am binding to the street. But without this width, I'd have to be saying things like self.address.street to get down to it. So this is just providing you with a convenient way to simplify the code a bit. To say, for everything inside this bound element, assume it's inside the address object. Right, this works a lot like the width statement that's in sharpen. The data bindings can be combined. So what am I doing here? I've got a list element inside this unordered list. It has a text binding, which is going to bind the value of some data value to the text object. But it also has a CSS binding. So it's going to pull the CSL set or whatever this function returns. And it also has a click binding. So if somebody clicks on this list element, then we're going to call this function. Again, remember, root is shorthand for the view model. So everyone is saying how this is going. And what's happening down here is just the same sorts of things we were doing all along. So for example, here's our data elements down here, which we're going to map to the bindings up there. Go to folder here is go to folder down there, and so forth.
Really stupid question.
There's only one view model. I wish there could be more than one, but you can't. There's only one view model. There are a lot of things that we can put on form elements that are handy. We can bind to the submit, for example, which is pretty handy. We can bind to the various check properties and so forth inside the form element. So we can build forms then where pretty much every one of the attributes of the form is pulled out of some piece of JavaScript rather than being hard-coded into the HTML. And that's kind of handy. And we can also do event-level data binding. Now, here what I'm doing is that I have a div, and I have a data bind at the event level. And what I'm doing is I'm binding the mouse over event to enable details and the mouse out event to disable details. And down here inside my view model, I'm providing the enable details and disable details methods that are going to be bound up here to the events on the div. Again, this is easy enough to do in JavaScript, but it's more convenient to do it this way. It's certainly cleaner syntactically.
If you go back on the slide, please. In this, when you are binding to an event, you are binding events for one particular div. If you have multiple divs, different elements, and you want to bind events for them, do you end up creating multiple things, like disable detail, enable detail for each?
No. You can bind this one function to multiple divs if you want to. Notice that there is this reference here.
Yeah, but if you need different function for each, you need to create different function.
You wanted a different function for each div, you have to create a different function.
So your view model basically can...
Could get quite large, yes.
Right.
There's only one.
And there is no way to break it down.
No, I wish
No,
there was.
okay.
Because in a single page web app, this thing can get pretty big. Because there are multiple virtual pages associated with the physical HTML.
Okay.
Right, more bindings. Now we're binding values, right? So here I've got an input field where I'm binding the value to username. Now before we were just looking at the text attributes. So I've got, again, some JavaScript that's got a view model in it. I have an observable username. I have an observable password. Up here in the login name, I've got a data binding of the value username and a data binding of the the value attribute of the password to the password input element. Right, so here the questions were coming up earlier about going in the other direction to the input elements. Here's how to do it. So essentially what we're doing here then is we're binding to specific events that happen inside the input elements as the input element is being manipulated. And these events, they work the same way with all the other bindings.
So the subscriptions are automatic for, okay, Knockout takes care of the subscriptions. So
Yeah,
that's all.
that's right. Again, like we all know how to do this, but it's easier this way. And then finally, it's possible to make custom bindings if you want to. So you can invent your own bindings. So here I've made a fade visible binding. And what this fade visible binding is going to do is execute this code as a side effect of whatever the update would be, and it's going to execute this code exactly once when the element comes, when the bound element is initially bound. So in other words, here in the H3 element, I'm saying I want to data bind using my custom fade visible binding, which is going to effectively be passed the result of evaluating that. So everyone understanding what I'm trying to accomplish? And that so this function then gets executed as the binding would trigger. This function up here is doing the initialization. Right? So in other words, the general pattern here is you create a field and put it inside Knockout's binding handlers object. Remember, this is JavaScript, so we can add new elements to objects at any time. This is not a compiled language, it's an interpreter. So I'm adding a field to the binding handlers object. And that field has to have an init method and an update method. And the init method is called once when the thing is bound. And the update method is called every time the thing is modified in some way. Is this making sense? All right. And finally, I was going to put up an example that was jQuery related because these things are tied into jQuery pretty heavily. And the notion of widgets is also tied into all of this. So here I have a simple button which is bound in the normal way. There's a data binding for the enable attribute. Right? Here I'm doing a jQuery button. And the difference is that I have added to the notion of the binding handlers this jQuery button custom binding. And so in other words, this JQ button binding is not part of Knockout. That's something that I'm inventing down here by adding a binding handler. And what it's doing is running a little bit of jQuery as a side effect of the bind operation itself. So what that little bit of jQuery is doing is it's replacing the current element with a jQuery button instead of a default out-of-the-box button. So as a side effect, we end up with a jQuery button here instead of a default out-of-the-box button. So again, it's a custom binding that's being used to pull this off. I don't need to do anything other than swap in jQuery here, so there's no update method on the custom binding. And I can then use that to make very complicated custom widgets. I don't think we need to go through all this code. But the point here is that this is a 5-star rating widget where you can click on the individual stars. But it is just a custom binding. So I created a star rating thing with this elaborate init code, which is doing nothing but creating these stars and getting them lined up and getting them initialized and so on and so forth. And then there's an update binding. It's caused automatically when you click on a star, and then it updates the UI in order to reflect the fact that the star has been clicked. And more importantly, it's going to update an underlying element in order to indicate that the star has been clicked. Value accessory here to be put into user. So again, I'll let you, I don't think there's much value in sitting here, given that we've now looked at so much code that our eyes are closed to. But the point that I'm trying to make with this slide isn't so much the details as the fact that it's possible. You can do this very elaborate widget thing. And of course, this is really hideous looking code, but you're only going to have to look at it once. Right? And then thereafter, you can just bind your star and you're done. Okay? Some questions? Any questions?
Do you have to have the binding handler in the same view model, like in have them somewhere and then call them, in your view model?
Sure. It's just JavaScript, they're just JavaScript functions. So JavaScript is JavaScript, you can call it from there.
With the observables, can you have your own custom listeners to that, which could say, you want to observable, and then whenever you update it, you can then send it to the server?
Yeah.
So with the stuff that you raised, do you get information about when you've got added and elements removed, or is it just a...
Well, remember, when you make something observable, you're effectively got a function that's called every time it's modified. So if what you want that function to do is an AJAX call up to the server to get it updated right then, then sure, go for it. Or if you want to cache the data and then call the server later, you can do that too. It's just JavaScript. But the point is that you at least have a hook that tells you this has been modified. So essentially what would happen, I like to keep the server as close to the client as possible, even if there's more network traffic. It's a side effect of that. So I tend to notify the server every time something changes in the UI. But that could be a lot of network traffic, right? You might want to just wait until somebody hits some button or something, something that means, okay, now you can talk to the server. Right, there's an important concept in microservices that I think applies here, which is that a microservice should be transactional in the sense that an operation should either complete fully or not complete at all. And so sending partial state information up to the server can be kind of risky because it's hard to wrap that into a transaction. Right, is that if you, on the other hand, do what amounts to a transaction out to the client level, that's easier.
So if you want to push something to the table, for example, does that mean you should only update the observable array after the server returns the success?
I think that's sensible, yeah. I think that's sensible. Okay.
You have to choose between AngularJS and Knuckle. Which one would you recommend?
You know, I tend to go to Angular now just because I like the curly braces. It's cleaner looking, right? It makes my code move a little bit simpler, but it is a little slower. And you know, so so far I haven't done a knockout or Angular heavy mobile web application. And at that point, I would if it was mobile, I would probably go to Angular. Because Angular is bigger, but it's, or no, rather the other way around. It's mobile, I would probably go to Nine because it's small. Right? If it's not mobile, then I think it's a 6 of 1/2 dozen together, which is bigger than one. Now there are Angular at this point has a more lively ecosystem. So there are extensions and so forth to Angular that somebody other than the Angular guys are building. And it's useful to have those. There's less of that kind of activity in the non-space. So I would kind of look at what is going on in the whole space and decide what you need to do the application that you're writing. But the main advantage of Knockout is that it's small. It's got a small space.
You started out sort of saying don't do MVC. Would you not combine Knockout and MVC?
Well, you could do MVC with Knockout if you wanted to be sure. You know, and but the way that I look at it is that it's not really MVC if a change in the UI directly impacts the change in the, because there's no controller
You
anymore.
always end up doing that anyway, though, because you start with just MVC and then there's a big Ajax.
Yeah.
It's
But
shut
we're
down.
eliminating the controller of this process, though,
Yeah.
is the difference.
Okay.
Right, so and it's the controller that gives us grief in MVC, right? Because we have to modify the controller every time we modify the model. So by eliminating the controller, we simplify things. And then, again, getting back to the very beginning of the class, right, which might even be more important in terms of this discussion than the details of Knockout versus Angular, is that from an architectural point of view, I like the idea of looking at this system as a single object that happens to have a UI piece that's running over here and a logical piece that's running over there. Right, so I think conceptually it's a good model. And the other important thing that it gets you thinking of is that composition model that I was talking about, right, where you have a big thing made of small things. That's very important. So if nothing else comes out of the session, if you end up not using Knockout at all, you look really closely at the way your web pages are put together and try and get them modularized in a way that when anything changes, the scope of the change is a single place. So that if you change a UI element for a customer, you do that once and the whole site changes without having to go in and change every page that the customer is displaying. Because that's really essential from the programming point of view. Okay? All right, we'll all be around the conference, so if you have other questions, feel free to gather. Thank you very much.